Hello, I'm Nivedita Rajiv, and this past summer I worked with Dr. Sahota and Dr. Wagner on a project titled Generating a New Mouse Model for Lesch-Nyhan Disease. So to give a little bit of background, Lesch-Nyhan Disease is an X-linked genetic disorder caused by mutations in the gene Hprt, which encodes the purine salvage enzyme, hypoxanthine phosphoribosyltransferase. And in humans, this causes it causes the formation of kidney stones as well as neurobehavioral symptoms. And there's also the deposition of uric acid in joints, which causes immense pain. And because of the neurobehavioral phenotype, this disease has been difficult to characterize, and most of our knowledge comes from rodent models. However, these rodent models are not sufficient in that they do not show the overproduction of uric acid and the neurobehavioral phenotype. And we think that this might be because of the presence of urate oxidase in mice, which is an enzyme that converts uric acid to allantoin, which is a soluble compound that is excreted through urine. And so we hypothesize that to create an effective mouse model, we need to knock out both Hprt and urate oxidase. And this was done using our breeding scheme through which we generated double knockouts, as well as single knockouts for both Hprt and urate oxidase and heterozygous mice. So the heterozygotes and the single knockouts were used as controls for the behavior tests that were conducted, and these behavior tests are surface riding, mid-air riding, Rotarod, open field, and Morris water maze. This figure shows the data for surface riding, which is conducted from days P5 to P9, and this assesses motor coordination and cerebellar maturation. Here, the mouse is placed on its back gently and released, following which the time for the mouse to turn itself upright and land on all four paws is measured with a maximum of 30 seconds. Here we see that all groups significantly improved in their ability to surface ride over the course of 9 days, with no significant differences between groups. The next test that we ran was mid-air riding, which also assesses motor coordination, cerebellar maturation. In this test, the mice are held 30 inches above a padded receptacle, ventral side up, and then released, after which the ability to mid-air ride and land on all four paws is measured, where the successfully riding themselves twice in all three trials is considered a success. And here we notice that all groups significantly improved in their ability to mid-air ride over the course of the study, with the Het wild-type group being significantly better at mid-air riding than the single knockouts for Hprt and urate oxidase. The next test that we ran was the Rotarod test, where the mice are placed on a rotating rod with a circumference of 6 inches, rotating at 12 revolutions per minute. And this rotating rod is placed 60 inches above a padded receptacle. And the time that the mouse is able to walk on the rotating rod is measured for a maximum of 30 seconds. Here also we see that all groups significantly improve at staying on the rotating rod for the course of the study, with no significant differences between groups. The next study is open field, which assesses locomotor and behavioral activity. In the study, the mice are placed in a plexiglass box and with a camera placed above it, and the AnyMaze software is used to measure the ratio of time spent in the center to the time spent in the periphery of the box. And this graph shows the results of that ratio, where there was no significant effect of day on either of the groups, and there were no significant effects between groups as well. Lastly, our final test is the Morris water maze, where a hidden platform is placed in one of 4 quadrants in a tub of water, and this platform is 1.5 centimeters below the surface of water, and the time to find the hidden platform after being placed in each of the quadrants for 5 different trials is measured for a maximum of 60 seconds. Again, here we see that each group significantly improves in the ability to find the hidden platform over the course of the 4 days, but there are no significant differences between groups. And for all of these studies, we do not expect single knockouts or heterozygotes to show any behavioral phenotype, so the results follow our expectations. We did generate double knockout mice, but the reason why we did not include the double knockout mice in our behavior studies is because the double knockout phenotype is lethal and the mice die within 5 to 10 days of age. Therefore, we were only able to carry the full set of behavior tests on the single knockouts, and the heterozygous mice. The knockout mice are the Hprt knockout mice are viable and fertile, but the urate oxidase knockout mice die at an early age due to urate nephropathy. The survival of these mice can be improved by treating the homozygous deficient pairs with allopurinol in the water supply, and this is because allopurinol is an enzyme that inhibits xanthine dehydrogenase, which is responsible for the formation of uric acid. And we did include allopurinol in the water supply for the generation of double knockout mice, but these mice still died within P5 to P10. The cause of death is still not clear, but it's most likely related to renal failure. And for the future directions for our experiment, we will be carrying out renal pathology and biochemical studies in the double knockout mice to determine the cause of lethality in these mice. Thank you.